right, my darlings, get excited. This is the last set of notes for this chapter. And we're doing more two-column proofs, but this time we're going to add in midpoints and bisectors. And remember, a midpoint just cuts a segment in half. It gives you two congruent segments. And a bisector, well, if it's an angle bisector, it cuts an angle in half. It gives you two congruent angles. You can also have a segment bisector, which gives you two congruent segments. So we're either going to be using definition of angle bisector, definition of midpoint. These are just basic definitions. And we're still going to include what we were working on in the previous one, so reflexive sides and vertical angles. All right, so example 1. We are given side MA is congruent to side AT, and segment HA bisects angle MAT. All right, so I'm going to mark what was given. Well, I'm given that these two sides are congruent, and then I'm given an angle bisector. But a bisector cuts an angle in half. So if we bisect angle MAT, that means these two angles are going to be congruent to each other. And we have this reflexive side. So all of this needs to get into our proof. So just like on the last set of notes, we start with the easy part, the given. Just write down what was given. Side MA congruent to side AT, HA bisects angle MAT, and just because it was given. So right here, this is a side congruent to a side, so I put a little S. This does not say anything is congruent to anything, so I cannot put anything next to it. But we marked on our picture that we have congruent angles, so I'm going to say angle MAH is congruent to angle TAH, and that's just by the definition of angle bisector. We were given an angle bisector. Angle bisectors give us two congruent angles. And now I can put a little A next to it because this actually says angle congruent to angle. And I had this reflexive side. So AH is congruent to AH by the reflexive property of congruence. And that's a side congruent to a side, so I can put a little S. And I now have three parts. And looking at the picture, it's two sides and the included angle. Two sides and the included angle. So the triangles are congruent by SAS congruence. All right, example 2. We are given angle P is congruent to angle T, and A is the midpoint of segment YR. So again, first thing, mark the picture. Angle P congruent to angle T. Midpoint. Midpoint gives us two congruent segments. So I can mark side YA congruent to side AR. And if you look, we also have this pair of vertical angles that I can mark congruent. So I now need to get all these markings into my two-column proof. So again, start with the easy stuff. Given angle P congruent to angle T, A is the midpoint of segment YR, just because that's what we were given. They gave it to us. So angle P congruent to angle T, I can put a little A right there. Midpoint, nothing there says congruent, absolutely nothing, so I can't mark anything. But I marked those two segments congruent, so I need to put that in my proof. Segment AY congruent to segment AR, and that's just our definition of midpoint. Now I have two congruent segments, so now I can put a little S right there for side. I also marked these vertical angles. So angle PAY is congruent to angle TAR. Vertical angles are congruent. And that says angle congruent to angle, so I can put a little A right there. So I have my three letters, but be careful because look, this says ASA, but notice my reason is AAS. It doesn't matter the order they're in here, it matters how they look on the picture. And this side only touches this angle. It does not touch this angle. So we have triangle PAY congruent to triangle TAR by angle side congruence. All right, and that's the last set of notes for this chapter.